Scalability has turned out to be a very important aspect from the user's perspective, because if the network designer is not aware of the scalability requirements, the overall goals of the network are going to suffer. Likewise, while the network is scaling up and it is expanding, if a plan does not exist, the situation would be negative. Here, we look at another important perspective of scalability, that is, when the number of nodes and the servers and the switching devices and the routers all increase, we'll have increased data access. This data access is actually governed by a very beautiful law called Metcalfe's law. We'll see that this law is actually manifesting itself in modern times. And this data access has certain connotations on the network design. If we say that scalability without continued access to data is useless, it would not be an overstatement. Because after all, scalability has been achieved to serve the customers with data requirements. The access to data actually implies that the users, no matter how many are these, must be provided with a continued 24/7 serviceability. In recent times, we have seen that social networking has emerged. Social networking has changed the way users communicate with each other, form communities and groups, and defy the basic client-server architecture. Similarly, we have seen that extranets, such as virtual private networks, need concrete topology definitions and bandwidth allocation. So the classical 80-20 rule has become null and void. Just for recollection, the 80-20 rule implied that 80% of the traffic is for the local area network and 20% of the traffic is for the WAN links. But the situation seems to be lopsided now. With such increased access to the World Wide Web and to the local network resources as well, the data is available now to more departments. So sharing between different departments is now a possibility. And the network services have a high utilization. It is interesting that Professor Metcalfe observed this, and he stated, which later turned out to be more or less like a law, he says that the community value in terms of dollars, in terms of the value-driven parameter, whatever you may give it a name, the community value of a network grows as the square of the number of its users. It means that if you've got 2 users, then the value that you get is 4. If you get 3 users, the value that you get is 9, and so forth. Why this square relationship? Professor Metcalfe's law is actually considered to be a benchmark and a practical manifestation of the growth like the World Wide Web. Mathematically speaking, Metcalfe's law is simply put the total number of connections or the links between the entities present. For example, if there were just 2 computers, there would be just 1 link. But increasing the number of computers, the expression is governed by n into n minus 1 divided by 2. This n square complexity expression shows that although the number of nodes are few, the overall connections between them are so many, so they can do a lot that they previously couldn't do. This observation of Metcalfe that later turned out to be like law is useful in so many ways in considering the possibility of making social networking more useful. If you look at this particular graph, it shows that as the number of people who are using the internet increase, the value of connections increases using Metcalfe. If the number of people is, let's say, a certain value, which is below the threshold given by the dotted line in the middle of this graph, this implies that the traditional applications such as file transfer, email, and basic browsing is there. But if all of these users start opening up connections between themselves, then new applications such as Facebook, Twitter, YouTube emerge. So the growth and of the value which is appreciated and rather sought by the people grows exponentially. So if we summarize, we conclude by saying that according to the Metcalfe's law, the total number of connections between the people is way more than the physical connections which are established to realize a network. This has a direct implication and impact on the total traffic load which is generated, and this has to be taken care of by the network designers.